Hello everyone, and welcome to the 23rd video in the TypeScript Game Engine tutorial series. So in this video we're actually going to start building out our gameplay mechanics. From the last video, this is kind of still where we are, so we still have this movement by keyboard and whatnot, and we're actually going to change that up. So the approach that I want to take in this video is I want to start with the test zone configuration, because that's going to be the baseline for everything that we're going to need, and then we're going to build our code to that. So the first thing that I want to do is just kind of tweak a couple values here. So under our duck, we have our XY position. I want to change the X to 33, and I want to change, and I've already changed the scale to 2. So that's fine for that. And here for the circle, I want to change the radius to 8.5. Okay, and that's because this scale has changed, so obviously this needs to be much smaller. So the next thing that needs to happen is we need to add a behavior. And we're going to name this player controller, and its type is going to be, let's call it player, and we need the name of the animated sprite. Let's actually call that animated sprite name, and we're going to call this duck animated sprite. Okay, and we need something called player collision component. So this is the name of the collision component that that we're going to be using to represent the player, which is just duck collision. And then we're going to need something called ground collision component. Okay, and I'm going to call this ground collision. Some of this stuff will make more sense when we actually jump into the code, but we just need a couple of references to the names of some components here. Okay, so the next thing I'm going to do is this test crate. I'm going to rename this to ground. And the position I'm going to change to the X is going to be 0, and the Y is going to be 458. And I'm also going to set, the scale to 1 for now, but I'm just getting it in here in case we have to tweak it later. Okay, and in the components, I'm going to rename this to grass, and the type is still going to be sprite. The material name is going to be grass as well. And then the width we need to set explicitly, which is going to be 330, and the height is going to be 22. Okay, and we don't need an origin, so that is gone. I'm going to rename this to ground collision. So this matches up with what we have here, this matches up with what we have here, this matches up with what we have here. The type is going to be collision, which is a rectangle. That's not going to change. We want 330 by 22 on that. Great, so that's really all that we need to do for the zone configuration at the moment. The bulk of our player logic, at least, is actually going to reside in a new behavior that we're going to create that is going to read this and react to it. So let's go ahead and do that now. So under behaviors, I'm going to right-click and add a new TypeScript file, and we're going to call this player behavior. And I'm just going to choose another behavior here. Let's go with this one. I'm just going to copy this keyboard behavior and paste it as a template, sort of. And I'm just going to change this to player behavior data, and I'm going to change this to player behavior builder, and then just player behavior. And so we need to update all these references here to match data. And then player behavior builder, I also need to go down here, change that at the bottom. And change this to player. So that way it lines up to what we're expecting as far as the JSON goes. Okay, so we have speed here, which we want to change to acceleration. And instead of a number, it's going to be a vector2. And it's going to default to new vector2, 0 and 920. Now, I will admit that a lot of the numbers that I'm about to use in this video were sort of predetermined. I did a lot of tweaking to find which numbers were going to be right for this, so I didn't spend a lot of time having to do that on the video. So I did figure some of these things out ahead of time. Public, we need to add a player collision component, and that's just going to be the name of it, so it's going to be a string. Just going to copy that, and let's change this to ground collision component, and then another public animated sprite name, also type string. Okay, so the first thing that we need is to change speed to acceleration. And then I'm going to copy this. Whoops, that needs to be changed from a number to, this actually needs to say set from JSON. Right. Okay. So we need, first we'll do animated sprite name. So I'm actually just going to copy this and put it in the else block because we want to check to see if it's undefined. Actually, I'm just going to copy that. So we'll say animated sprite name must be defined in behavior data. Wow, I spelled animated wrong, didn't I? Spelled that completely wrong. Okay. So let's just change that up. Alright. And whoops. Yeah, this needs to be a string. Right. So animated sprite name. Okay. Next is going to be, it's pretty much going to be the same, almost the same exact code for the player collision component and the ground collision component. So I'm just going to paste copies of that code and just update it accordingly. Okay, we've already changed this. Alright, so I'm going to remove everything in the update, and I'm going to change, I'm actually going to delete this. So let's create private acceleration, which is a vector2, private velocity, which is vector2, and we actually want to default that to vector2.0. And we want a private isAlive, which is a boolean, which is going to be equal to true by default. And then, actually, I'm just going to copy these properties from here and just convert them to privates. Okay, one more thing that we need is we need private sprite, and this is going to be a animated sprite component. So this is actually where we're going to use some of that logic that we made in the last video to retrieve components, references to components. Okay, so in the constructor, we want to say this dot acceleration equals data dot acceleration. This dot player collision component equals data dot player collision component. This dot ground collision component equals data dot ground collision component, and this dot animated sprite name equals data dot animated sprite name. Okay, and we also want to subscribe to a couple messages. So in order to do that, we are going to have to say this behavior implements iMessage handler, and we can control dot implement that. And let's just move this down here for now. Change that to public. Okay. And so now we can say message.subscribe, and we're going to subscribe to the mouse down message, and message.subscribe, and we want collision entry plus this dot player collision component name, and then we want this as the handler for that. So this is that that method, or the message rather, that we are sending out in the collision manager. This is where we're going to wind up actually using that. We also need to add a public update ready, and this is the primary component that's actually going to use that, which is why I wanted to get it in place early. So we'll first call super.updateReady, just as a good practice, and we want to obtain a reference to the animated sprite. So we'll say this.sprite equals this.owner, which is the sim object that this is attached to, .get component by name, this.animated sprite name, as animated sprite component. So this right here is where all this stuff sort of starts to come together a little bit, as far as being able to grab references of components. And so what this actually requires is that this behavior has to be attached to either the same object as the animated sprite or a parent of the animated sprite. In our case, it's actually going to be attached to the same owner. Okay, so the next thing we need is a sanity check. So we say if this.sprite equals undefined, we actually need to throw a hard error about that because we're not going to be able to do a lot of the things we need to do otherwise. So we'll say throw new error, and we'll say animated sprite component named this.animated sprite name is not attached to the owner of this component. That string is really long, so I'm actually going to put it on 2 lines. Okay. Alright. So, the next thing that we need to do is I want to go ahead and define a few private methods that we're going to wind up having to call. And so, let's add a private isFalling, which returns a Boolean. And this just returns this dot velocity dot y is greater than 270. 220. So basically, we're sort of in a free fall state, we'll call it, if our velocity is 220. So remember that positive is down, negative is up. Okay, next one is a private should not flap. And this is returning a Boolean. And this basically determines whether or not the duck should be flapping his wings. And so we're going to return this dot velocity dot y is greater than, we'll say again 220, or not this dot is alive. Right? So if we're dead or we're in free falling, then we should not be flapping. Okay. Next one is private die. And again, actually this is return type void. So we just set this dot is alive to false. And we're actually going to want to trigger something in the audio manager. So we're going to want to say play sound. And we want to play sound dead. Right? So dead, if we look in sounds, it's just like a punching or a hitting sound. So whenever we die, that's the sound that we hear. Okay. We also want a private decelerate, return type void, and we'll say this dot acceleration dot y equals 0, and this dot velocity dot y equals 0. Right, so this basically stops everything happening dead in its tracks. Next, we need a private on flap. So this is when the user inputs, in this case probably mouse or touch control. So this is when the duck should essentially flap his wings. So if we say if this dot is alive, because obviously we don't want to be flapping the wings if he's dead, this dot velocity dot y, we want to minus, or set that equal to minus 280. So basically it's going to add velocity upward. And then we'll go ahead and play a sound as well. So audio manager dot play sound, and here is where we're going to play flap. Okay. And one more thing that we're not going to use right away, but we are going to need this, is on restart. So this is basically going to reset sort of the state of the duck. So we'll take in a number, and again, that will make a lot more sense when we actually go to implement this. But for now, this dot owner dot rotation transform dot rotation dot z equals 0, right? So we're going to zero out any rotation that's happened. In 2D, all rotation is basically the z-axis. this dot owner dot transform dot position dot set. We're going to set to 33 and y. 33 is just sort of again another pre-calculated starting position. We could change this up to make this configurable, but for right now I'm not going to bother with that, just for the sake of brevity. So we'll say this dot velocity dot set 0, 0. This dot acceleration dot set. We'll say again 0 and 920. So we'll basically be setting it back to its original value. This dot is alive is true, and then this dot sprite dot play. So we'll turn back on any animation if it was turned off. And then finally we just register the builder here. Okay, so I think as far as our private methods, I believe that's all of them that we need. Alright, so the next thing I want to go ahead and implement is the on message. So we'll say switch message code. In the case of mouse down, we're going to just say this dot on flap break. Nice and simple. So if we receive a mouse down message, we're going to flap. We're going to add some upward motion to our duck and make him flap a little bit, so he's not just free falling. So the next one is case collision entry plus this dot ground collision component. Whoops. Player collision component. Sorry about that. Let's go ahead and put our break. Okay, so if we have a collision with the player component, we want to check to see what that is. So the first thing is going to be let data collision data equals message dot context as collision data. And we're going to just check if data.a.name equals this dot ground collision component, or data.b is equal to this ground collision component. So in other words, if we collide with the ground, we want to say this dot die and this dot decelerate. And then we're going to go ahead and send a message. There's nothing that's going to intercept this right away, but let's go ahead and send it anyways. Send player died. And we'll pass this as the sender. Okay, nice and simple. So if we hit the ground, we stop moving essentially, and we mark ourselves as dead and handle the event accordingly. And that's it for onMessage. So the meat and potatoes of this is actually going to wind up being in the update loop. And so in the update loop, the first thing we're going to want to check is if this is alive is false. So if not is this alive. And if we're not alive, we simply return. That's it. Otherwise, we need to handle a lot of things. Now, what we're going to be handling in this is going to be doing a lot of operations based off the time. And the time that comes through is basically the number of milliseconds. And we actually, for the purposes of this behavior, we actually need to convert that into seconds, just to make things a little bit easier to deal with. So I'm going to store off a variable called seconds, and we're going to say that's equal to time divided by 1,000. Right? So it just converts our milliseconds into seconds. The next thing we're going to do is add to our velocity. And we want to say this acceleration. And we want a clone of that because we don't want to mess with the actual acceleration itself. And we want to scale it by the seconds. Right? So what this basically is saying is for every update, we want to add to the velocity by the acceleration scaled by the time difference, so that we get a consistent result even if we drop some frames. And so what this is going to do is it's basically going to make the duck fall faster and faster over time, and we'll cap that out here in a second, but it gives us a nice way to sort of control the velocity and sort of constantly add gravity to that. So next thing we need to do is we need to limit max speed. So we'll say if this.velocity.y is greater than, let's go with 400. This.velocity.y equals 400, right? So if we've gone over 400, we want to sort of max it out at 400, because any faster than that, it's going to move so fast off the screen you're not going to be able to see anything. The other thing that we want to do is we want to prevent flying too high. Right, so we'll say if this.owner.transform.position.y is less than -13, and I'm actually going to copy this, and we just want to set it equal to -13. And then we also want to set the velocity to 0. And what that's going to do is it's going to be sort of like the duck hits a ceiling and it won't be able to go any further up. That needs to be velocity.y. And so it provides us with a ceiling so that you can't fly infinitely sort of up and off the screen. It sort of boxes things in for us a little bit. Okay. So the next thing that happens is we actually apply the velocity changes to the position of the object. So we can do that by saying this.owner transform position, and we will add to that position. And we'll say this.velocity.clone, again, because we don't want to mess with the actual velocity. We want to scale that by seconds, and then convert it to a vector 3. And this is where that 2vector3 that I mentioned before was going to be used, is because position in our transforms is a vector 3, but we're storing our velocity as a vector 2. So we basically just need to add the z component so that we can actually just quickly and easily add it to our position here. Okay, and the next thing is if this velocity dot y is less than 0, meaning we're flying upward, we actually want to affect the z rotation on the owner object. So we want to say this dot owner dot transform dot rotation dot z, and we want to subtract from that math.degrees to radians. This is where we needed that. And we want to say 600. And we want to multiply that by seconds. Right, so this degree seems like it's kind of extreme, but when we multiply it by the seconds, that's such a small number that it actually winds up shrinking that down to something that that makes a little bit more sense. Okay, let's see. So the next thing we need to do is we need to sort of clamp this or set a minimum on this. So I'm just going to copy this and say if the rotation z is less than math.degrees to radians -20, then we want to set it to equal this -20. So we're sort of half clamping it, if you will. Alright, so the next thing that we want to do is we want to say if this dot is falling or not this dot is alive. So in other words, if we're free falling or we're dead, we want to affect the rotation again. So we want to say this rotation z plus equals math.degrees to radians, 480 times seconds. Okay, I'm actually just going to copy this code here and just modify it for our needs here. So we want to say if the rotation is greater than, let's see, we want 90 in this case. So we don't ever want to go, we don't want to rotate any more than straight down. So we'll just clamp that at 90 degrees. Okay. So the next thing is we need to say if this dot should not flap. We need to actually stop the animation. So we need to say this dot sprite dot stop. Okay. Else we need to say if not this sprite is playing, this dot sprite dot play. So if we're not already playing, play the animation. If we should not flap, then let's go ahead and stop the animation. And last, we just call super update. So this should be, I believe, everything that we need for this to run. So let's go ahead and build and run. And there we are. So we can see that every time I click, the duck sort of flaps up a little bit. Probably ought to work on tweaking the animation timing a little bit. He also, you can see that the feet right there, if I spam this, I can only fly so high. If I go all the way to the bottom, I'm dead. So that's really the first part of this game. That's really about half the mechanics of the game, to be completely honest. It's a pretty straightforward game. So the next thing that we're going to do is we're going to add in the objects that you have to sort of fly in between. And that will actually complete the mechanics of the game. But I'm going to do that in a separate video so that this one doesn't get too long. So I hope you guys have enjoyed this. I hope you've learned from it. If you haven't already, consider subscribing, and I will see you guys in the next video.